Okay, and on number 3, if I multiply both sides of this equation by dx, that's going to leave me with 6x plus 1 y squared dy plus 3x squared plus 2y cubed dx is equal to 0. And this is my n. This is my m. When I do the partial derivative of m with respect to with respect to y, this x term drops out, and here I get 6y squared. And the partial derivative of n with respect to x gives me a 6y squared. So my partial derivatives are equal. It says that this is exact. And so let's see, which one would be easiest to integrate? 6x plus 1y squared dy or 3x squared plus 2y to the third dx? I think I'll start with my dx. We're going to let f, which is a function of x and y, equal the integral of 3x squared plus 2y cubed dx, which when I integrate with respect to x, I'm going to increase my exponent to 3 and divide by the new exponent, 3. That'll cause these 3's to cancel. It'll give me an x to the third. Plus, on the second term, it's going to put an x in there. 2xy to the third. Plus, because I'm integrating with respect to x, plus some function of y. Okay, so now I do my first partial derivative of f with respect to y. Take the derivative of this function with respect to y, and that first term drops out. On the second term, bring the 3 down so that we have 6xy squared. And on this third term, I'm going to get g prime of y. And this should be equal to n. When I distribute through by the y, I get 6xy squared plus y squared. And notice that these 6xy squareds cancel each other out to leave us with g prime y squared, or g prime of y, is equal to y squared. To undo the derivative, we want to integrate. That'll give us g of y equals the integral of y squared with respect to y. And here when you integrate, you want to increase the exponent by 1, divide by the new exponent, and then plus c. So our solution is f. We get x to the third plus 2x y to the third plus g, where g is y to the third over 3 plus c is equal to 0. Now, this is the answer, and if you want to leave the answer in that form, you may. If you want to solve this for x, you can, because we do have a y that can be factored out. So I'm going to factor out this y to the third to leave me with 2x plus 1/3. And I'm going to bring the other terms over to the right side. They'll become negative. Equals negative x to the third minus c. And then if I divide by 2x plus 1/3, bring that up here. It's going to give me y to the third equals negative x to the third minus c over 2x plus 1/3. And you'd want to get rid of that complex fraction. You can get rid of the complex fraction by multiplying by 3 over 3. And I think I'll leave this as y to the third, rather than taking the cube root of both sides. Multiplying by 3 over 3, we get negative 3x to the third minus 3c all over 6x plus 1. And there's our answer.